In this video, we'll be looking at Bronsted-Lowry acids and bases. Now we have videos on the introduction to acid and bases. We have videos on hydrolysis and hydration. Now, if you haven't seen that yet, you can check the description and find the link to those videos in our playlist. All right, so let's begin. Now we are looking at classes of Bronsted-Lowry acids and bases. Remember we said Bronsted-Lowry's definition of an acid is a proton donor. Acid is proton donor. And we said a base is a proton acceptor. All right. So what are the classes of Bronsted-Lowry acids and bases? Now, the first one we'll talk about is monoprotic acids and bases. So number one, we have monoprotic acids. Monoprotic acids. Now, when we say monoprotic acid, we are talking about acids that are capable of donating only one proton. So these acids donate only one proton. Well, so you find out that there are acids that have more than one acidic proton, which they can donate. But when it comes to monoprotic, just like the name suggests, mono means one and protic from proton. So when we say monoprotic, that means that particular acid is capable of donating only one proton. So when it takes something like hydrogen fluoride, so we'll take HF, hydrogen fluoride, you find out that fluorine has only one acidic proton. So if this should dissociate, we'll have only one H plus and fluoride F minus. Okay, so the fact that this particular acid can give us only one proton, it is a monoprotic Bronsted acid. Okay, now let's look at another one. Let's take ethanoic acid, CH3COOH. Now what happens to ethanoic acid? It can give out only one proton and form ethanate, CH3COOH. So you find out that it is only this proton which is acidic. So it can give us only one proton, making it a monoprotic acid. Now, what about the bases? The same way we have monoprotic acid, we also have monoprotic bases, right? We have monoprotic base. Now, how will you define a monoprotic base? A monoprotic base will be capable of accepting only one proton. Capable of accepting only one proton. Remember what Bronsted and Lowry said about bases. They said bases are proton acceptors, and there are bases that can accept more than one proton. But if it can accept only one proton, then we say it is a monoprotic acid. So let's make this C. Monoprotic acid. All right. So let's look at some example. Let's take HS, HS minus. So remember that hydrogen sulfide is originally H2S. So the fact that we have HS minus means that it has already lost a proton. Now, this structure, this chemical here can only accept a proton. So it accepts a proton, H plus, and it will form the acid back H2S, hydrogen sulfide. Okay. So the fact that it can take only one proton means that it is a monoprotic base. Now let's take water, H2O. Now if you dissolve an acid in water, it's going to give H plus in the solution. So what is going to happen? The H plus will not exist in solution. So the water molecules will pick that H plus and give us hydronium H3O plus. Now, once this is formed, it is not capable of accepting any more proton to to form something like H4O. So we'll say that it is monoprotic because it can accept only one proton. Okay. Now, the second thing to look at is polyprotic acids, polyprotic acids and bases. So let's look at that. So number two, we have polyprotic. So polyprotic acids are capable of donating two or more protons. Okay, capable of donating two or more protons. All right. So let's look at an example. Let's take hydrogen sulfide. Hydrogen sulfide. Now, hydrogen sulfide is H2S, just like we saw in the monoprotic bases. It is H2S. Now, when this dissociates in solution, it will give us 2H plus and S2 minus when it is fully dissociated. So you realize that both hydrogens here in the hydrogen sulfide are capable of going out as protons. So the fact that we have more than one protons given out will say that what this particular acid is a polyprotic acid. All right. Now let's take another example. Let's take sulfuric acid H2SO4. H2SO4 will give us 2H plus and sulfate SO4 minus. So you realize that again we have two hydrogens that are given out with is more than one. So the fact that we have more than one makes it a polyprotic acid. All right. Now, what are polyprotic bases? Now, for the polyprotic bases, they are capable of accepting more than one protons. So we have polyprotic, capable of accepting more than one proton. All right. So let's look at some examples of polyprotic bases. Now let's take the sulfate SO4 2 minus. Now this SO4 2 minus is capable of accepting two protons and forming H2SO4 back. H2SO4. Okay. So realize that it has to take more than one proton to form this back. So the fact that it's taking more than one makes it a polyprotic base. What about phosphate? Let's take PO4 3 minus. It is capable of taking as much as three protons to form H3PO4, phosphoric acid. So that makes it a polyprotic base. Okay. Now, one last thing I want us to look at is amphiprotic substances. So let's write the amphiprotic. So what is an amphiprotic substance? It is basically a molecule or let's say an ion that can behave as both Bronsted acid and a base. So this species behaves as both Bronsted-Lowry acid and a base. So let's quickly look at some examples. Let's take hydrogen chloride HCl in water H2O. Now, what is going to happen when this acid dissociates in the water? We are going to have hydronium ion H3O plus, and then we have Cl minus. Now, in this case, we could clearly see that the water is a proton acceptor, and so this becomes our acid, while the water is the base. So water is accepting the proton to form the hydronium ion, which is going to be our conjugate acid, and it's Cl minus our conjugate base. Okay, now let's look at another example. Let's take NH3 in water. What is going to happen? We are going to have NH4 plus and hydroxide. So you realize that in this case, water is donating the proton. Water is donating the proton to ammonia, which is forming the NH4 plus. So in this case, we'll say that the water is the acid and the ammonia is the base. Okay, so water is a stronger acid than ammonia. So if that is the case, then since water can behave as a base and as an acid, we'll say that water is an amphiprotic substance. It's an amphiprotic substance. Now we can look at some other examples. Let's take HS minus. HS minus. Now looking at this, you can tell that it is hydrogen sulfide giving out a proton to form this. So what happens? This one, when it loses the second proton, when it loses a proton, let's say, so minus H plus, okay? What is going to happen? We are going to have sulfide S2 minus. Now, what happens if it rather gains a proton, H plus? We are going to form the hydrogen sulfide back. So as a result of that, we'll say that HS minus is an amphiprotic substance. Amphiprotic or amphiprotic species. Okay. Now let's look at another example. Let's take bicarbonate HCO3 minus. Now this is from carbonic acid, which is supposed to be H2CO3 minus. So what happens when we take the second proton away? So let's subtract a proton, H plus. What we are going to have is carbonate CO3 2 minus. But this same species is capable of accepting the proton. So when we add a proton to it, H plus, what are we going to have? We are going to form the carbonic acid back. H3, sorry, H2CO3. So you realize that again, this one is also amphiprotic because it is capable of accepting a proton, which is making it a base, and is capable of donating a proton, which is making it an acid. Now let's look at our last example, which is HPO4 2 minus. So this is from phosphoric acid. Now we know that phosphoric acid has three replaceable or protons that could be donated. Okay, So what happens if this species loses a proton? When it's giving out a proton, it's going to form phosphate PO4 2 minus. Now, what happens if it gains a proton? If it gains a proton, it's going to be so plus H plus is going to be H2 PO4 PO4 minus. So this is going to be 3 minus here, 3 minus. So realize that these species are all amphiprotic because they are behaving as both a Bronsted-Lowry acid and a Bronsted-Lowry base. Now watch out for our next tutorial on acid and bases. Remember to like this video and also subscribe. Thank you.